Morena koutou. Thank you for joining us today. I know it's a bit of an awkward time with Matariki holiday coming up, and we've shifted to Wednesday. And I know we've got a big karakia at 12 o'clock. So I'll try and keep this relatively brief. We'll get us out by 11:45 at the latest so everyone can have a cup of tea and go to karakia. But yeah, thank you for joining today. So the workshop today, as part of our Te Manawa Haukura workshop series, is on Tātari, Raraunga, Tatau, or quantitative data analysis. But first and foremost, ko waio, no tia mana aho, engari I whano mai aho ki Amerika, I tai mai ki Aotearoa, I te tō ruamano me iwa, ke Waitakere aho e noho ana I nāia nei. Ko Tim Angeli-Gordon, taku ho rangatira, ko kai rangaho matua ia, I roto I te manawa haukura hoki. Ko Bella Pullum, rawa ko manawa ora Angeli-Gordon aku te mahine. Ko ngā puhi me Ngāti Whātua o rata tūpuna I aku te mahine. Engari he Pākehā hau. He Pākehā hau. So I think that's a bit about who I am, but also what this presentation is about my mahi. And I wear a couple of hats in my mahi as well. So my role in Te Wānanga Aotearoa is Senior Rangaho and Innovation Manager is my title. So a lot of what I do is support kai rangaho within the organization and kai mahi to set up their rangaho programs, look at securing funding and those sort of administrative support processes. But I also do research myself, and in particular, I focus on medical research and health-related research. My background is in biomedical engineering. So I went to university in the States at the University of Michigan before I moved to Aotearoa. And then I did a degree in biomedical engineering. I did a PhD in biomedical engineering at the University of Auckland, and then stayed working there for about a decade, doing research on gut health. And then shifted across to Te Wānanga Aotearoa about a year and a half ago. So I'm really excited to be here and excited that I'm able to contribute in, I guess, a variety of ways, not only still doing a bit of research myself, but also supporting others. So I think that I wanted to cover that because I think it frames up sort of my perspective and where I'm coming from. And also my educational background is purely in Pākehā institutions, international as well. So that's an important frame of reference, I think, to keep in mind. So to cover a little bit of an overview of what I plan to go through today, I was going to focus on my own research in gut health from that quantitative perspective, and I really want to use that as an example of how we can use quantitative analysis, and I'll try and apply that then to more general quantitative analysis methods that can be applied more broadly hopefully in your rangaho and your research activities. And then lastly, look at a couple of exciting opportunities for quantitative analysis, particularly looking at some emerging techniques of using spatial data to integrate with quantitative analysis. So just a very brief warning, there are some medical images in my talk. I do medical research, but none of them are overly graphic, so it shouldn't be a problem. But if you feel uncomfortable with those, prepare yourself, please. So shifting now into some of my gut health work, I like to start with the motivation. And for me, the motivation is always a people focus. And so we can see on the screen here a young woman named Ruby Hill. She is a late teenager, I believe, in this photo, about 19 years old. And she was diagnosed with a disorder called gastroparesis when she was, I believe, about 19. And you'll see a transformation when I show the next photo, which is only a couple of years later. That's her in a hospital bed, suffering from this disorder called gastroparesis. So gastroparesis literally translates to stomach paralysis, but it's a disorder that's characterized by very severe symptoms, very severe stomach symptoms of abdominal pain, bloating, nausea, and vomiting, and also a term called early satiety, which means when you eat a meal, you end up feeling full very early. So actually, many of the patients become malnourished or really struggle to get nutrition. And so this is Ruby. It says in the bottom of that image, which is from a news source, she was at her lowest weight of 42 kilos in that image. And there's another photo of her at that point weighed just 22 kilos. And unfortunately, she passed away shortly after that. So I think this is a poignant reminder of the people that are impacted by these disorders, and what it looks like for those people. Um, I've been very fortunate to connect with Ruby's mom, and we do some work together in terms of advocating for these gastrointestinal disorders, which tend to be quite underserved in many communities. And she's been a supporter of our research financially as well through a trust that she set up for Ruby. So I think this is a sort of a starting point of what these conditions look like on a personal level. And they're um, underpinned by one, a challenging diagnosis. So it can be very difficult to diagnose the problem. And then secondarily, limited therapies are available. So in Ruby's case, it took years to get her disorder diagnosed, and there was no therapy that was effective for her in the end. Um, so if we look, sort of zoom out a bit from Ruby as an individual and look more at how big this problem of gastrointestinal disorders is as a whole, we can see that gastroparesis, the disorder that I talked about with Ruby, affects less than 0.9% of the global population, so less than 1% of the population, which is relatively limited. But it's a growing health problem because it's closely linked with diabetes, which is a worldwide epidemic, and it affects over 14% of adults worldwide. If we look at just gastroparesis alone in diabetics, it's 44% more common than in non-diabetics, so it's very closely linked with that growing health issue. And then if we look at gastrointestinal disorders more broadly, they affect up to 40% of the global population, and they result in over $100 billion in the US alone in healthcare expenditure per year. So it's a massive problem, these gastrointestinal health issues. And what I've done here is try and show an application of how we can use quantitative data to highlight the problem or the topic that we're looking at with our research. So you can see here there's a variety of quantitative data that shows us what this problem of gastrointestinal disorders looks like in our population. And I think this is a technique that many of us can apply in our research of looking at framing up our topic and showing what our topic looks like. And then you'll also see that I used references. So these are actual data, which I think in today's political climate may be a surprise or uncommon, unfortunately. But these are actual data. They're relatively recent, you can see. So all of them are from 2020 or onwards, so in the last 5 years. And they're all from reputable sources, either academic journals, so that journal Gastroenterology is one of the very top clinical journals in the field, or the World Health Organization is a very reputable health organization. So I think looking at quantitative analysis and quantitative data in our research, it's always helpful to look at the sources where those data come from, to make sure that you're getting those data from sources that are reputable, and looking at how they got those data as well. So sort of the take home from that is that we can use quantitative data to describe the motivation, magnitude, and impact of our kaupapa. So in other words, why is our kaupapa important? why should people care about it? And I think that's a really important foundation to start from when we're building our Raraunga research. So I'm going to shift focus a little bit now and look at, as a bit of a case study or example, my specific research that I focus on, which is the electrical control of the stomach and intestines. So what we're going to see here is a view from inside the stomach. This is from a device called an endoscope, which is essentially a camera that you put down your throat. And we can see this is inside the stomach, and we see those big ring contractions that are moving down the stomach. Each of those contractions is actually triggered and coordinated by electricity that sweeps through the muscle, causes the muscle to contract, which breaks down and moves your food throughout your stomach and intestines. It's very similar to your heart, where each of your heartbeats is triggered by electricity in the muscle. The stomach's the same, but we're about 20 to 30 years behind our understanding compared to scientists in the heart. And personally, I think it's always interesting to look back in historical context and look at where we came from. So this is a photo of a man named Walter Alvarez. He was a professor in California and also a medical doctor. And he's credited with discovering this electrical activity of the gut. So we can see actually an image from one of his papers from 1922 on the right-hand side. And there's a little diagram in the bottom left corner, which is a sketch of a stomach. And there's a couple of lines in the bottom of the stomach and the top of the stomach. And those lines are electrodes that he's placed on the stomach. So tools that he's placed on the stomach to measure the electrical activity. And then those traces up above are the signals that he got from that electricity of the stomach. And so we'll look at those a little bit more, because this is the data that we study today still over 100 years on. So if we zoom in one of those signals, one thing that he didn't do at the time was label his axes. So on the x-axis on the bottom is time going across, and on the y-axis, the vertical axis, is the voltage. So that's a measure of the electricity. So I've added those in. And what we can do with these data is look at different quantitative metrics. So if we look on the left, we can look at how tall that voltage is. That gives us what's called an amplitude. And in this case, I've labeled these based on typical numbers or typical ranges. So we can see the amplitude is about 1 millivolt. That's a unit of measure for electricity. And we can look at how frequently or the time between these individual electrical events. So these individual peaks in this trace are when the electricity arrives at that electrode in the stomach. And we can see that it's about 20 seconds in between each of these events. We can then calculate a frequency from that. So 1 over the period means we get about 3 of these electrical events per minute in the stomach. And these are all examples of ways that we can quantify or put numbers to the observations that we're looking at. So we're able to quantify the amplitude, the period, and the frequency in this case. And another important aspect here is looking, when we quantify our data, at the units that we're reporting. So in this case, we're reporting on time and we're reporting on voltage, so measures of electricity. Now, similarly, we can use these quantitative metrics to compare between events. So in this case, I've used as an example one of the electrical events early in the recording and later in the recording, and we can see that the amplitude actually changes in time. So we can look at variations between those events. And in that case, sort of a take-home point, and I think a wider application of this example, is that we can use quantitative analysis to describe our data and observations. What do your data look like? And then if we look at data from different people, so here I've extrapolated as an example 3 different people and longer duration recordings, we can then start to study cohorts or groups of people or populations of people. Or we could apply this to other things. It doesn't have to be people. And we can use quantitative analysis to answer questions like, what does all slow wave activity, that's a term for the electrical activity in the gut, what does all slow wave activity look across all people in this group? Does person A have different slow wave activity compared to person B? Does the slow wave activity of this group of persons A through C, those three people I showed, differ from slow wave activity from another group of people? So those are some of the questions that we'd look to answer in this field. And the way to do that is to use statistics. I don't really want to go deeply into statistics because it's statistics. And I don't think it really excites too many people. And it's a whole separate topic that we could spend many, many talks on. But I thought we can look at a bit of a case study in terms of how we can use statistics. And so I'll skip ahead now and look at what I talked about previously was quite a bit of historical data from the stomach. And now I'm going to fast forward to into the 2000s. So fast forward about 90 years and look at where we're at today, or where we've progressed to today. And so this is some of the work that I've been involved in over the past 10 to 15 years. And what we've developed here are high resolution electrical mapping techniques. So in this, what we looked at in that previous example, that historic example, was from a single electrode placed on the stomach. And we're able to see the electrical activity from that single location and look at quantitative aspects of that electrical activity, like the amplitude or how frequently the electrical events occurred. But what we weren't able to see was what was happening in other regions of the stomach. So what we've done here is developed what's called high resolution electrical mapping. On the left-hand side, excuse me, you can see an example of some of our tools that we use. These are our high resolution electrodes. So each of those little dots is an electrode. There's 256 of them in that patch, which is 6 centimeters by 6 centimeters. So it's quite a dense grid of electrodes that we're able to then place directly onto the stomach. And we do that via surgery. So in the middle is an example of a patient who's had open access surgery and along their abdomen. And those little tannish coppery colored ribbons are our electrodes going into the abdomen onto the stomach. So that was another important piece of this development, was that these electrodes are sterilizable and they're able to be used in human patients in an operating theater. And what we're able to do with this is to create spatial patterns of this electrical activity. Rather than looking at it as a single source, we can actually map it in space across the stomach. And on the right-hand side, you can see this is a computerized model developed by one of my colleagues named Ping Du that incorporates all of these many recordings from these many electrodes across many patients into a summary of what that activity looks like. And hopefully you can see, so these are electrical events that are colored. The amplitude is colored. And you can see hopefully that you've got those yellow rings of activation, which look very similar to that recording we saw from inside the stomach with those contractions. Now, this is another way of looking at these data. So this is, each of those dots is an electrode from our electrode array, and we can then show the propagation across of the electricity moving down the stomach. And on the left is a healthy case. So that's those rings of activity moving down the stomach. On the right is a diseased patient that we studied. And we can see that the activity is much more chaotic. It's not rhythmic. It's not a ring moving down the stomach, but it's actually activating from lower in the stomach in an abnormal location. And this is what we found in 2 different disease cases, one being gastroparesis, which is what Ruby suffered from and we talked about earlier, and another being a disorder called chronic unexplained nausea and vomiting. I quite like presenting about that disorder because the name is quite self-explanatory. Patients suffer from chronic nausea and vomiting, and there's no known explanation for it. Now, what we found was, I'll just reverse. We found that all of the patients experienced these abnormal electrical patterns in their stomach. And the reason that was a significant finding is because previously, using those lower resolution techniques, like I talked about, that Alvarez developed and were used for almost 80 or 90 years since then, we were restricted to looking at only frequency as the quantitative metric. What we found with the spatial analysis is that actually in each of these circled, the N signifies normal frequency range. So all of these patients, 5 of our 9 patients, had abnormal spatial patterns, but normal frequency, which means that these patients were missed when we looked at just the traditional quantitative metric of frequency. And so I think a take home there is that while quantitative analysis is a really powerful tool and it can add to our sort of tools or methods for our Raraunga research, like any analysis technique, it has its limitations. And so what we saw here is that for many, many decades, we were focused on frequency and looking at abnormal frequency of these events. When that did capture a subset of abnormalities, but there was this whole other realm of abnormalities that were spatial, and we weren't able to capture them until we expanded the data that we were collecting and looked at a spatial aspect of the data as well. So I think it's important for us to consider what are limitations of our data and also what are the limitations of the quantitative analysis that we're performing. Moving on and looking at the same study, so that CUNV, that's our diseased cohort. So cohort just means a group of people. So this is our diseased group on the left or in the middle column, and our control cohort is our patients with healthy stomachs on the right. And here we can see an application of statistics like I talked about earlier. So rather than going into a deep dive on statistics, we can see how we can use statistics to describe the what we're studying. And we can see here on the top line, the number of patients that we studied is 9 versus 9, so consistent number of patients that we've looked at. The median age, so median is a statistic that you can calculate in the age range. We can compare between is 50 versus 57, so similar but slightly different, and the age range as well is similar but some nuanced differences. We can also look at the breakdown of sex, female versus male participants, or female and male participants, numbers of 8 to 1 in one cohort in our diseased cohort and 5 versus 4 in the control cohort. And again, that's something where we can look at limitations where we've got a female-dominated group with our diseased cohort. Although that does align with what we know about these gastrointestinal disorders is that there's higher incidence in females. And on the bottom line, we can see our mean and standard deviation of our recording duration. So this looks at how much data did we collect from each patient. And so altogether, this helps to describe the data that we've collected and describe the populations that we're studying. And I think this is another technique that almost anyone can use in their research or in their Raraunga, is to use quantitative ways, so put numbers to the data that you're collecting. And this is applicable in qualitative research as well. If you're running interviews, wānanga, focus groups, you can still describe the number of people that took part, how long those sessions were, how many questions were asked, and those sort of quantitative data help to describe the richness of the data set that you're collecting, and I think can be really valuable. And then I'll just briefly talk here. We also collected tissue. We looked at cell counts, and so this is a representation graphically of the cell counts of the specific cells that are responsible for this electrical activity in the stomach. And we can see that our control, or a healthy population, has on the right-hand side has the highest number of these cells. And then our 2 diseased populations, the chronic nausea and vomiting in the middle, and our gastroparetic patients, both have depleted cells. And so these are specific cells that are responsible for the electrical activity, are depleted in these patients. And so we suggested that this is a cause of the disorder, is this cellular depletion associated with the electrical abnormalities. And so again, this counting of our cells was a way for us to suggest a potential underlying cause. And I think that's something that that can be applied more broadly in Rangahau and in research is using quantitative analysis to look at what are potential causes. And I've highlighted a couple of terms here because when we start to look at cause-effect relationships, we need to be really careful around what we've measured and whether we've actually measured the cause and effect, or whether we've measured two pieces of data that are associated and suggestive of a cause. And that's the case in our study here. We've identified that the cellular depletion is associated with electrical abnormalities, which are associated with the disease patients, but we haven't shown a direct cause-effect relationship. So just something to keep in mind. And again, going back to that limitations of analysis techniques. So sort of wrapping up on this work, but I wanted to touch briefly on where we're pushing with some of this at the moment. So I talked about those high resolution mapping techniques and the fact that they're surgically invasive. So we actually place those electrodes directly on the stomach via surgery. So at the moment, we're pushing towards minimally invasive options. So this is a new device that we can place endoscopically. So that means down the throat. Each of those silver bands you can see in the middle image is an electrode. Again, there's 64 of them. We're able to deliver that down the throat via sedation. So there's no global anesthesia, there's no surgery. We can inflate the device in the stomach and then record these electrical patterns non-invasively or minimally invasively. So that's a really exciting development trying to push us towards a new way to diagnose disorders. And then another aspect of what we're looking at is called ablation. So this is a technique that's really commonly used in heart medicine and cardiology. It's essentially delivering focused energy to effectively burn the tissue in a very controlled and careful manner, which creates scar tissue and prevents electrical activation or propagation in that region. So what we're looking at doing here is eliminating those abnormal activation patterns like I showed on some of those previous slides. So in the disease patients that have abnormal electrical activation, can we use ablation to eliminate those regions and restore normal activation? And this is a technique that we can then use to look at those cause-effect relationships. And this is the technique that we've recently received funding for from the Health Research Council. And Joni, my wife, is also contributing to that project, where we're starting to look at the gut-brain axis from a Te Ao Māori perspective to link that in with these techniques as well. So just reflecting back now, and this is the wrap-up phase, so we're on target to get everyone out of here in time for karakia. And hopefully have a bit of time for questions or discussion. And I'd love to hear some of the feedback and where other people use quantitative analysis. But reflecting back to that motivation of Ruby Hill, what she went through, and that take-home point of patients like her are suffering from challenging diagnosis and limited therapies. And clinicians are also challenged by those same things. When a patient comes in to a clinician wants to have tools to be able to answer their questions or to address their problems. So I think patients and clinicians are both suffering. And what we've started to do over the past 10 plus years is develop new techniques to better diagnose these disorders through looking at these electrical signals, and also to try and deliver therapy with ablation, all of which have been underpinned by substantial quantitative analysis of these signals and the patients that we're looking at. So if we look back at the overview that I talked about at the beginning, we've looked at an overview of the gut research that I focus on and use that as an example of how quantitative analysis can be used in research. And I think we've also looked at that second point of how can you use quantitative analysis in your own individual Rangahauan research. So I touched on a number of points throughout, but just to highlight, we can use quantitative data and analysis to describe the motivation, the magnitude, and the impact of our kaupapa. So in other words, why is your kaupapa Rangahau important? We can use it to describe our data and observations. What do our data look like? and we can use quantitative analysis to describe different data sets or populations. So are two things or are two groups similar or different? Again, we get into stats in that case and also descriptive quantitative metrics. And I think I'll also comment here in that I'm an engineer. I love numbers. I love quantification, but I also um, really love qualitative research, and I love the people's focused aspect of research. And I typically start most of my talks talking about Ruby or talking about a patient or talking about people because I think that's really important. So I just wanted to acknowledge here as well that quantitative analysis, I think, sits best when it's used alongside other techniques. And we've heard from some of the other workshops recently around qualitative analysis techniques and other analysis techniques. And I think that mixed methods research approach can be a really powerful tool where we look at not only the individuals and the populations, but we're able to record quantitative data from them and use that to tell an entire sort of story and develop a very rich understanding of whatever our kaupapa is that we're studying. Um, and an example of that is on the right-hand side. That's a former PhD student that I worked with, Zara. She loved art. She was a fantastic artist. And she was one who did a lot of those ablation studies that I talked about very briefly. And she published one of her papers in that journal there. And the journal cover, her study was highlighted on the journal cover using an artistic rendition that she developed of some of her histology images. So some of the microscopic images of her tissue, she created an artwork, which is shown on the cover there. And so I love that. For me, that's really rewarding because it brings in those personal aspects as well. So we've got a very deep physiological study. We do a lot of, you know, boring, I'll say, or nerdy engineering. I'm a self-proclaimed nerd, so I have no qualms in saying that. But and then we've got this beautiful piece of artwork that has brought Zara's personality into that project as well. So I love those sort of aspects of linking different types of research methods. So hopefully that covers off a little bit on number two as well. And then just talking about some emerging exciting opportunities. One is in spatial analysis. And so I talked about that with my own work already. So just a reminder that we've talked about some of that value in adding spatial analyses, but there are other areas more widely that are emerging quite rapidly in this field. One of which is called geographical information systems, or GIS mapping. And I know these are things that a number of people on the team in Te Manohokura are working on. It's very common in urban design and environmental type research where people add different layers of geographical mapping to create and show an environment. And what we can do with this sort of mapping is then add quantitative data to look at different aspects. So if we add quantitative data on deforestation rates, we could actually project what this environment could look like in the future. Similar with building proliferation rates, if we can simulate what the environment would look like. If we add quantitative data on traffic rates or number of people moving around these regions and car ownership, we can then simulate things like traffic flow and where congestion may occur and problems that could emerge in these environments. So I think that's quite an exciting area where we can look at that addition of spatial information with quantitative data. And another example, and this is from Te Ara Encyclopedia Online, but this is a map of Maori land ownership from 1860 on the left to 1939 on the right. And I think this is a very poignant visualization of what occurred over that period and has continued to occur. And we could look at, again, adding quantitative data here. So we could actually overlay land values, say modern day land values, to this map to look at quantifying this problem and this issue and what has occurred. So I think hopefully those are a couple of examples of where we can use quantitative data plus spatial mapping plus wider societal type issues from a rangaho or research perspective to look at studying different kaupapa. And with that, that's the end of the talk today. So hopefully we've learned something. So I'll turn it over if anyone's got questions, comments, or general observations. Would love to have a kōrero.
I have a quick, I don't know whether it's a question or observation. It's always terrible, isn't it, when someone's like just wants to share their reckons at the end rather than a question. But
no, that's great.
I think for a lot of people, the quantitative analysis can be really daunting. And I guess what I would observe is that normally, you're working alongside people. So not to be shy to ask for help, certainly at different research institutions, there's always going to be people who have that expertise and can support you. And so I guess it would be, my observation would be not to be shy to reach out and ask for support with that, rather than thinking that you can't do it. It's just something that you can't do yet.
Yeah, I think that's an awesome kōrero. Thank you, Murray. I totally agree. And that's why I put my email address on that last slide, and my name, just to remind people to reach out if you're interested in talking. I'd said I'm a self-proclaimed nerd, and love numbers. So this is stuff that I love looking at and trying to problem solve in terms of where we can add quantitative data to different problems or link with other people. And I certainly don't have all the answers. There's plenty of other people that I reach out to all the time as well. So I think that's a really great point. Thank you, Murray. Does anyone else have any comments, questions? Or even examples of where quantitative data can be used to build their rangaho?
I just wanted to say, Tim, that it was a really cool reminder for me about the ways that you can undertake quantitative work when you're doing qualitative data. That was a really good reminder for me as I'm working on my application at the moment. So ngā mihi for that. That was really interesting, though. Thank you.
Yeah, no, thank you. I think I think it's really nice when we can use different methods together. It's one thing I really like to do, even when I'm deep in the quantitative work, is really look at qualitative aspects as well. How does this impact? I mean, for me, it's health. So how can this impact patients' lives? How can this impact how people go about their day-to-day work? How can this impact how clinicians are able to serve populations? And I think vice versa, it can be useful as well when you're working in that social space or the art spaces, reminding what are those sort of quantitative makes it sound real formal, but what are those sort of numbers based aspects of the work as well. Any other whakaaro before we shoot off for karakia? Yeah, James, do you have
Yeah, thanks, Tim. That was awesome. I just had a random thought because I sometimes wear a different pōtai, and so I'm on a trust for a spatial science kind of trust. We support mainly students into spatial sciences, but we're trying to set up a kind of like a general grant, so that'll be quite small, up to $2,000. But I thought I'd just mention it because once we do get that up and running, that'll be open if people are interested in any of that spatial analysis type stuff and wanted to apply for a small grant for, whether it's equipment or time or something to kind of jump into that, or training courses, stuff like that. We're especially focused on supporting like underrepresented groups, so Māori, particularly women in GIS, GI sciences as well, is another big group. So yeah, there's just a random kaupapa that I'd chuck onto the end there. But no, that was awesome, and thanks for it was a nice reminder as well, because I haven't done spatial analysis myself for a little while, and I was like, oh, I need to get back into that.
Yeah, I think it's always fun looking at what other people are doing and thinking, "Ooh, how can I add that into my kete?" No, that's awesome. Thank you, James. I think it's always good to look out for those opportunities as well. And I think that's another aspect of this is where, and part of why I talked about sort of the two hats that I wear in terms of rangaho and innovation, rangaho support work, and my rangaho as well, is that a lot of intersection in terms of funding and how we can create applications to get our research funded or our rangaho funded. And I think those quantitative elements can be really impactful. What I talked about at the beginning in terms of framing up your problem or framing up your kaupapa, it doesn't have to be a problem, but framing up your kaupapa and funding from funding perspectives, they want to understand what that is. And to put it bluntly, the funders want to know why they should care. And I think that's a blunt way of putting it, but why should people care about this? And a way to show that is using numbers. And I think you can apply that to many, many different areas. But even looking at how much, say, education, how much money is invested in certain areas of education, is there an area that you're looking at that's very underinvested but is really important? That can be a way of highlighting that by looking at dollar investment or in rates of different kaupapa. So I think that's a really important aspect in both the rangaho side, but also this funding side of setting up your projects is being able to explain your topic to other people and more or less why they should care. I feel like I've talked enough for today, so unless there's any other whakaaro, maybe we'll wrap up.
Yeah.